message, cryptographers use inverse matrices, particularly those who construct the encryption method. To be encrypted and decrypted, a message is created in binary format as a sequence of numbers and is encrypted and decrypted using the traditional code theory. When encrypting a message with an encryption matrix, the inverse of that matrix can be used to decrypt the message. In this video, we are dealing with the inverse of a matrix. Let's see. 2 multiplied by what gives 1? It is 1 by 2. That is 2 multiplied by 1 by 2 gives 1. Now, what multiplied by 9 gives 1? 1 by 9 with 9 will give you 1. What are these two numbers called? Each of these is a reciprocal of the respective numbers. 1/2 is the reciprocal of 2. 1 by 9 is the reciprocal of 9. Now, my question is, does a matrix have reciprocal? Let's say we have matrix A. In matrices, identity matrix represents 1 or unity. So we can ask, A multiplied by what will give us I, or the identity matrix? What can we have here is such that product of these two matrices will give us the identity matrix. Instead of writing 1 over A, we write something called A inverse. Yes, this is the inverse of matrix A, which is represented as A with -1 as the superscript. A times A inverse gives us the identity matrix. Again, what multiplied by A gives us identity matrix? A inverse. That is, A inverse multiplied by A gives us the identity matrix. This is the concept of inverse of a matrix. Its product with A gives us the identity matrix. So, we can define the inverse of a matrix mathematically. If A is a square matrix of order M and if there exists another square matrix B of the same order M such that AB is equal to BA is equal to I, then B is called the inverse of matrix A. In such cases, when it satisfies this condition, we say matrix A is invertible. Let's look at an example. Given matrix A is equal to 2, 1, 1, 1. Matrix B is equal to 1, -1, -1, 2. Find AB and BA. Perform matrix multiplication on A and B. We get AB is equal to 2, 1, 1, 1 multiplied by 1, -1, -1, 2. Perform matrix multiplication. We get 2 minus 1, -2 plus 2, 1 minus 1, -1 plus 2, which is equal to 1, 0, 0, 1, which is equal to I. Similarly, we get BA also equal to 1, 0, 0, 1, which is equal to identity matrix. Thus, B is the inverse of A. In other words, B is equal to A inverse. A few points to remember. The very first point is necessary and sufficient condition to satisfy matrices A and B is that they should be square matrices of the same order. The reason rectangular matrices do not possess inverse matrix. Second point, if B is the inverse of A, then A is also the inverse of B. That is, A is equal to B inverse. Next, we will see some theorems and proof related to the inverse of a matrix. Theorem number 1. It says about the uniqueness of inverse. The theorem statement, Inverse of a square matrix if it exists is unique. Let's see the proof. Let A is equal to Aij be a square matrix of the order m by m. If possible, B and C are the two inverses of matrix A. Now we have to prove that B is equal to C. Since B is the inverse of A, we can write AB is equal to BA is equal to I. Since C is also the inverse of A, we can write AC is equal to CA is equal to I. Now, matrix B can be written as B into I. Now, it can be substituted with A into C. Then, applying the associative property, we get BA within the brackets into C, which is I into C, which is equal to C. Hence, proved. Now, let's see the next theorem. Theorem number 2, statement, if A and B are invertible matrices of the same order, then AB inverse is equal to B inverse into A inverse. Let's see the proof. We know by the definition of the inverse of a matrix, AB into AB inverse is equal to I. Now, multiplying both sides by A inverse and we get A inverse into AB inverse is equal to A inverse into I. Rearranging, we get A inverse into A within the bracket into B into AB inverse is equal to A inverse. Now, A inverse into A is nothing but I. So, IB into AB inverse is equal to A inverse. That is, again rearranging, B into AB inverse is equal to A inverse. Now multiplying both sides by B inverse. So we get B inverse into B into AB the whole inverse is equal to B inverse into A inverse, which is equal to I into AB inverse, which is equal to B inverse into A inverse. Now we get final AB inverse is equal to B inverse into A inverse. Hence, proved. Now, we have learned the concept of inverse of a matrix and the theorems behind this concept. Now, we will extend our discussion on how to find the inverse of a matrix. We can find the inverse of a matrix using the elementary matrix operations. To find A inverse using elementary row operation, here are the steps. Let's see one by one. Given matrix A such that A inverse exists, write A equal to IA and apply a sequence of row operation on A equal to I into A. Now check A is equal to IA becomes I is equal to BA. If it is yes, B is the inverse of A. If it is no, continue the process until we get I is equal to B into A. Similarly, to find A inverse using column operations, given matrix A, write A is equal to A into I and apply a sequence of column operations on A is equal to A into I. Now, check A is equal to AI becomes I is equal to AB. If it is yes, B is the inverse of matrix A, else continue the column operations until I is equal to AB. Note, while performing elementary operations, if we get all zeros in one or more rows in matrix A on the left hand side, then we can conclude that A inverse does not exist. Let's see one problem. Find the inverse of the matrix. Matrix A is equal to 2, 4, 4 minus 2. Let's solve it. Given matrix A, first write A is equal to I into A. So 2, 4, 4 minus 2 is equal to, what is I? 1, 0, 0, 1 into A. Apply row operations one by one till we get I is equal to BA. So first I apply the row operations on the second row. So R2 becomes R2 minus 2 into R1. So we get 2, 4, 0 minus 10 is equal to 1, 0 minus 2, 1 into A. Next row operation apply again on the row number 2. So R2 becomes R2 is equal to minus 1 by 5 R2. And the change is 2, 4, 0, 2, which is equal to 1, 0, 2 by 5 minus 1 by 5 into A. Now R1 becomes half of R1 and R2 becomes half of R2. We get 1, 2, 0, 1, which is equal to 1 by 2, 0, 1 by 5 minus 1 by 10 into A. Now perform on R1. R1 becomes R1 minus 2 into R2 and we get 1, 0, 0, 1, which is equal to 1 by 10, 1 by 5, 1 by 5 minus 1 by 10 into A, which is of the form I is equal to B into A. Repeat, I is equal to B into A. So we can store the row operations with this step and the matrix B is equal to 1 by 10, 1 by 5, 1 by 5 minus 1 by 10, which is equal to the A inverse. However, determining the inverse of a matrix using elementary operation takes a long time, and there is a standard method for doing it, which we will look at the next video. Now, let's summarize the entire section.
Manorama Horizon. Learning made simple.